Hello students. So we were discussing various aspects of wave reflection, refraction and transmission in third unit uh, while teaching the concepts of reflection, refraction and transmission. We have seen various topics like perpendicular, parallel polarization, Brewster angle, total internal reflection, evanescent waves, Snell's law, and the necessity of those things, right? So even we talked about the power. So while the course is going on, actually I have taken some problems uh, and I've solved them in the course sessions itself. Okay, so when the course sessions related to the course were taking place, I have also solved some problems so that you can understand the concept side by solving some problems also. And after solving some problems while teaching the course, I also uh, had a session, means visiting the previous gate questions or previous ISRO and DRDO public sector job questions, means competitive exam questions, usually which includes the concepts which you have learned in this unit, right? So we also dealt with some multiple choice questions where I have given you some suggestions regarding how you go with the problem, right? So in this session we will solve even more interesting problems, right? So that you can use this as a reference for when you're trying to solve your assignments, or right, when you're trying to understand the solving of questions uh, even more attentively, right? So you can always go back and look at the questions which are discussed in the while the course is going on. Okay, they are in my session lectures which are already in the classroom. So but let us start this session. This I'll consider as a tutorial part, but though we are already dealing with tutorial problems in the course session also, so I suggest you to include those problems also as a tutorial problems, and solve those problems also for your examination purpose or for your understanding purpose. Okay, so let us start with this question. So you can see that an electromagnetic wave is traveling in free space with an electric field component which is given like this. Okay, and there are three questions. You have to determine the frequency, wavelength and the magnetic field and the time average power. So the question here is the electric field is given. First of all, if you try to see this electric field is represented in phasor format. So it is in phasor format. How can I say it? Because there is no e power j omega t term. Of course, sometimes you can also have e power j omega t term, but the matter is it is not in the format of time domain. So it is not dealing in means it's in a complex domain. So when you want it to be in the time domain, you need to represent it in sine or cosine format, right? Sine or cosine signals. So I don't say it is in the time domain format. So we can convert into time domain format, but the question does not ask for time domain format. But even though it does not ask for it, just for the purpose of revisiting the concepts. So if you want to convert this expression into time domain, right? So I can see that it is a function of y comma z. But if I want this time variation also, you just multiply it. You take the real part of 100 e power j 0.866 y plus 0.5 z, and you multiply it with e power j omega t. Of course it's an ax cap. So if you do this, you will end up with 100 cos of omega t plus 0.866 y plus 0.5 z and a vector in ax cap. So you can see this is your time domain equation, and this time domain equation is actually written in a phasor format like this. Okay, so from this thing, from the electric field which I was given here, I can understand that there are three, as I was saying previously. When you write an electric field, you should always look for three things. Okay, so one is the magnitude part, and the other is which talks about the phase, and this talks about the, of course, this phase gives you the direction of wave, and this part is the direction of field. So from the question, what I can see is the field is actually oriented in x direction, and because the magnitude is a uniform, it means it does not change with any x comma y comma z. It's a uniform plane wave. Of course, it's a plane wave because this phase becomes constant in this plane. Okay, so what is the equation of the plane ante? So this is your equation of the plane. 886 y plus 0.5 z is equal to constant is a plane. So in this plane, the phase is going to become constant, or they are constant phase points with the uniform magnitudes. It's a uniform plane wave traveling in arbitrary direction. So how do you, what is the general format? So the general format, for a wave traveling in arbitrary direction. So for a wave traveling in arbitrary direction, I can say the electric field is given as E naught bar e power minus j k bar dot r bar. Okay, so E naught bar is a constant vector. So in our case, what is E naught bar? If I look at my equation here, electric field equation, I can see that I can write the same thing as 100 times of ax cap into e power minus j times of, okay, so you can see here, if you know what is r bar and k bar, from there you can estimate the similarities here. So k bar usually has a kx x component and ky in y component and kz in z component. Means it can have spatial variations in x, y and z directions. And r bar is simply the position vector x times of x cap. Of course, here the unit vectors are taking a convention of ax cap, ay cap and jz cap. So let us move with the same convention. And the position vector is like x times of ax cap, y times of ay cap and z times of az cap. So if you take the dot product between these two, okay, what you'll end up with? You'll end up with kx into x plus ky into y plus kz into z. So I see that in this bracket minus j, this term is actually kx into x plus ky into y plus kz into z. So what kind of similarity I can see from this expression is, so I can write the same format as minus j times of 0.0 times of kx, okay, plus, oh sorry, 0 times of x plus, I mean sorry, not plus, with a minus sign, I can say minus of minus uh, 0.866 times y minus 0.5 times of z. Okay, so you can see the whole thing has a minus sign, so it cancels out with this minus and you get a plus. So that is what you have here. So I have this field. Okay, so I can see that this looks like my electric field, a constant magnitude within some direction, which is E naught bar, and this factor is nothing but k bar dot r bar. So what I can see is, from here I can say what is a k bar vector. From here I can say this factor becomes kx, and of course this whole minus of this whole factor becomes kx, and minus of this whole factor becomes ky, and minus of this whole factor becomes kz, right? So in order to have the similarity, so from here what I can tell is, what is a k bar vector? Simply the k bar vector, I get it as is 0 times of ax cap plus minus 0.866 times of ay cap plus 0.5 times of az cap. Okay, so this is what we have, right? So we have the k bar vector and we have the magnitude and all. So right now the next part to do is, the question asks for to find the omega and lambda. So it is asking for omega and lambda. So how do you get omega? First of all, what is the magnitude of k bar? We have studied in our theory that the k bar is wave vector and the magnitude of wave vector is always equal to the phase constant beta. Okay, so the magnitude of your k bar vector should be equal to your phase constant beta. So if that is your scenario, beta, because the wave is traveling in free space, okay, so in the free space beta is nothing but omega times of square root of mu naught and epsilon naught. Okay, so you can see that the square root of mu naught by epsilon naught, this value is nothing but 1 by 3 into 10 to the power of 8. Now you need to calculate omega, but all you need is what is the magnitude of k bar vector. Sorry, my bad, here there is a minus sign. Okay, so because here there is a minus sign, so k bar vector is I can see the magnitude of k bar is square root of minus 0.866 whole square plus minus 0.5 whole square. Right, so what is this value? If you put it in your calculator, you will get the value is close to 1, because the 0.866 is nothing but root 3 by 2 whole square plus I can say minus square is positive, so I can say 1 by 2 square. Okay, so you can see the value will be 1. So the magnitude of this one is equal to 1. So if this is equal to 1, that means omega is equal to, right? So omega is equal to, so you bring this 1 by 3 into 10 to the power of 8 to the other side. So you get 3 into 10 to the power of 8. The unit is radians per second. Right, so this is your omega. So the question asks for omega. We have the answer for omega. So now let us try to get the other answer, which is nothing but wavelength. So we know that the phase constant k beta, it can also be expressed as 2 pi by lambda. So because we have this beta is equal to 1, I can see that lambda is nothing but 2 pi meters. Right, so we have our answer for the first question. So the next part is to deal with the magnetic field. So how do you calculate the magnetic field once we have an idea regarding the electric field? Okay, so the answer is means we calculate it in a simple way. In fact, we have seen how to calculate the magnetic field from the electric field, and we have derived an expression in the course. If you remember, we know that electric field is perpendicular to magnetic field and it is perpendicular to the direction of propagation k bar. So keeping this in mind, and because we are dealing with the transverse electromagnetic waves here, in those kind of scenarios, means if you are dealing with particularly these kind of waves where you have transverse electric, magnetic, and the wave direction is all perpendicular, mutually perpendicular, in that scenario we had a derivation, and in fact we derived that magnet, means we derived this derivation from the Ampere's law, del cross of I mean not the Ampere's law, I mean once you know the electric field, so it is del cross of h bar is equal to minus j omega mu times of p bar. So this is your phasor notation of your I'm sorry, my bad, del cross of E bar is equal to minus j omega mu times of B bar. This is your phasor notation of Faraday's law. So from here we have oh, I think I'm making many mistakes today. So del cross of E is equal to minus j omega mu into h bar. So from here you can calculate what is the value of h bar. Okay, so we have done this derivation, and in fact we have proved that h bar is given by 1 by omega mu k bar cross E bar. Okay, so this is what we have. So if you don't remember it, I always suggest you to go back to the videos where I have taught this. Okay, so maybe it can refresh your memory. So it is a straightforward question. So I have the magnetic field. To calculate the magnetic field, all you want is k bar vector. So in fact we have the information of k bar vector. So k bar vector is like this, minus 0.866 times or because to make it easy I'll write, or maybe first I'll write like this, 0.866 times ay cap minus 0.5 times of az cap. Okay, so this is your k bar vector. So conveniently I'm writing as 0.886 as minus root 3 by 2 times ax cap minus 1 by 2 az cap. So this is your k bar vector. Okay, so once I have the k bar vector, what is E bar vector? E bar vector is known already. E bar vector is like this, 100 times of e power j 0.866 y plus 0.5 times of z ax cap. So all you have to do is take a cross product between these two, and to do that, before, what is omega and mu naught? So you know that omega we got it as 3 into 10 to the power of 8, and mu is nothing but mu naught in this scenario. Okay, so you can deliver this value. So first of all, what is this curl? Curl can be expanded as, because it's all in Cartesian, ax cap and ay cap and az cap. I can see that k bar does not have an x component, sorry, so this is y. So k bar does not have an x component, and it has a y and z component. So this is minus root 3 by 2 and this is minus 1 by 2, and I can see that there is only x component for this one, which is 100 times of e power j 0.866, or maybe we neglect this 66 and we write it as root 3 by 2 y plus 1 by 2 z. Right, so that is your x component. So this is your x component. You don't write ax again. Okay, so these are your component values. So that's what I have written, and y component is 0 and x component is 0, and here you have 1 by omega times mu naught. So we have the value of omega also. So I can see from here that when I take the cross product, there is no x component because they go to 0. Okay, and after that, if I go for the y component, okay, if I choose the y component now, I can see that there is a y component. Okay, so I can write this cross product as let me write like this, 1 by omega mu naught minus of ay, so minus of ay cap times so you have 0 minus minus 1 by 2 times of 100 e power j root 3 by 2 y plus 1 by 2 z. So this is what we have for ay, and after that we have z component also. You can see there is z component, so it is plus times of az cap times it is 0 minus of minus root 3 by 2 times 100 into e power j root 3 by 2 y plus 1 by 2 z. Right, so that's what you get. So I guess you can substitute the omega value here or mu naught here, and if you do that, you'll end up with this kind of answer. So you substitute the other things here, you end up with an answer like 1.33 times ay cap, okay, uh, minus of yeah. Think okay, fine. So here I can see that uh, you will get a minus sign here probably. These are the minus ay cap, and you get a plus sign here. Times, of course, there is your e power j root 3 by 2 y plus half times of z. You get milliampere per meter. Okay, so this is how you will get for the magnetic field expression. Okay, right. So let us calculate the time average power in this scenario. So I can see that so to calculate the time average power of this wave, so in any case the average power, time average power, sometimes we use this average convention, right? So is nothing but half times of real part of E cross H conjugate is what we have to do. Of course, we have the expressions for electric and magnetic fields. Because the wave is traveling in free space, you can write this thing as half times of a real part of modulus of electric field square divided by eta naught, because eta naught is a real number and E square is also a real number. So this basically ends up with modulus of electric field square divided by 2 times of eta naught, intrinsic impedance. Okay, so this is the magnitude part. Okay, what I have written here is the magnitude part. This is also the magnitude, because E cross H gives you a vector. Okay, so I need to have some direction here. So that direction is what you need to find. Okay, so if you go in this way, means you will only get the magnitude of the power, time average power, but you don't get the direction of it. So you might say usually it will be in because the power is traveling in yz plane. You can see that you have both y and z components in your k bar vector, so it's traveling in yz plane. So all I can tell you is the the power should also have y component as well as x component. Okay, so usually it ends up like that. So but it is better, because in this scenario The problem is you might go with this modulus of e square by 2 eta naught, but that helps only if you have a single component and the magnitude is what you want. But in this scenario, it is better to use our expressions here. So we know the phasor format expression. So E bar is, so you need to use this formula only in the phasor format. So your E bar is 100 times of e power j is 0.866 y plus 0.5 z in ax cap. But whereas your h bar is given by minus 1.33 times ay cap minus 2.3 times of a, sorry, plus az cap into e power j times of this factor here, and of course it's in milliampere per meter. Okay, and this is in volt per meter. So you have to take the conjugate of this. You can see when I take the conjugate, because these are all real numbers, simply j plus flow, you replace it with minus j. So when you put this and when you take the cross product, okay, I guess you'll simply end up with half of those values. Okay, so you'll end up something like this. So you get so when you take the cross product with an x and minus y component, okay, so when you take cross product with x and minus y component, so you get ax cross ay is z, but because there is a minus sign, you get a minus az. Okay, and when you take cross product with an x and z component, you get minus y component. So you basically end up with something like an answer like this when you substitute these values here. 11.44 times of ay cap minus 6.3631 times of az cap. Okay, so this is what you'll end up with, and this is watt per meter square, because it's a time average power. Okay, per density, it's a power density. Okay, so this is your average power. Of course, if you take the magnitude of this vector, definitely you'll end up with the value of modulus of electric field square divided by 2 eta naught, which is 100 square divided by 2 times of 120 pi. Right, you'll end up with that value. You can take the magnitude and you can check it also. So but this is your time average Poynting vector. So this is how you solve this problem. So now let us move on to the next one. So the next problem, you can see here again the electric field is given, but now they have given an interface also. So the question is like an electric field is given and they're asking what is this uniform plane wave traveling in air. Electric field is given, they're asking what's a magnetic field, and if the wave encounters a perfect conducting plate normal to the z-axis. So basically here is your z-axis if I assume. So the wave is coming normally like this, and this on the z-axis or z equal to 0, you have a perfect conducting plate. So there is a PSA, right? So if you know that if there is a perfect electric conductor, there is no field on the other side, so the transmitted field is 0. Whatever wave hits here, it's going to get reflected back, because for a perfect electric conductor we know that the reflection coefficient is always equal to -1. So keeping this in mind, let us start our analysis. First of all, the incident electric field is given. They're asking you what is the incident magnetic field. So to do this better, let us convert this electric field expression into phasor format. Right now you can see there is a cos and sine terms, so it's in time domain. So to convert it into phasor format, what I will do is here sine omega t, I'll replace it as cos of omega t minus beta z of minus pi by 2. Okay, so that gives you again the same sine, okay, sine value. Right, so we have this. So I mean, if I can write it like that, I can say A is nothing but in the phasor format. I can write it as 40 times of e power minus j beta z ax cap plus 40 times of course, maybe I'll go step by step so that you can don't get any mistake. Maybe I'll write it like this: 40 times of, I can write 40 cos as real part of 40 e power j omega t minus beta z ax cap, and of course plus, I can say plus 30 times of e power j omega t minus beta z minus pi by 2 times ay cap. So this is your, I can, if I take real part to these exponentials, I will get back this equation. So here if you neglect this e power j omega t term and the real part of it, so basically, so this is your time domain. So your phasor form is where you neglect the e power j omega t and real part terms. So means you don't write this real part and e power j omega t any longer. If you do that, you get 40 times of e power j minus j beta z ax cap plus 30 times of, I can see here e power minus j beta z is there. Along with it, there is an e power minus j pi by 2 times ay cap. So what is this value? What is e power minus j pi by 2? So this value is nothing but equal to minus j. You can check it. You have your Euler's principle cos theta plus j sin theta. If you put it there, you get minus j. So I can replace this factor here with simply a minus j. Okay, so minus j times, or I can write this as minus 30j ay cap, or in fact I can put this even in a better format like this. So 40 ax cap minus 30j ay cap into e power minus j beta z. So you can see it's an elliptical kind of pole. Of course here the polarization is not the matter. So here is a wave, this is coming normally, means it's incident normally. So if this is your electric field, so the first question asks for what is your magnetic field. Of course the expression for magnetic field is always same. You go with 1 by omega mu times k bar cross E bar. Okay, so I can see that in my equation k bar is actually beta times of ax cap. You can see there is only beta z and beta into z component, sorry not ax, az. So there is only z component, so your k bar vector is simply beta times ax cap. And what is your electric field vector? That is given like this. So if you put this 1 by omega times of course you basically end up with an answer which is in terms of omega. Okay, if the frequency is given then you can do it, but I guess the frequency is not given here in the question. So let us put it as omega itself, and you have mu naught because it's free space. And to take the cross product, I can see I have ax cap, ay cap and az cap. And for the k bar vector there is only x component which is beta, whereas for the electric field I have x component which is 40 times of e power minus j beta z, y component as minus 30j times of e power minus j beta z, and z component is 0. Okay, so let me expand it and write it like this. Okay, so you have your cross product, so you need to do the cross product here. So I can see that there will not be any x component, sorry, there is an x component. Okay, and of course there will be a y component, but there will not be any z component in the det, and I take the determinant. So let me write these values so that you can get an answer here. So when you take the cross product, okay, so for the x component I can see that the x component hi is nothing but 1 by omega mu naught, and you have your x component ax cap times of minus of minus 30j e power minus j beta z into beta is your ax component, and coming to your ay component, okay, you get minus of ay cap times so 0 minus beta times of 40 e power minus j beta z. Okay, so this is your y component. So once I have the x and y components, so I can see in both terms there is beta common, so I can bring beta out. Okay, so I'm trying to bring beta out here. So if I bring beta out, so this becomes beta by omega mu naught, okay, times of I can see there is 30, minus of minus becomes positive, so 30 times of e power minus j beta z into j, okay, there is a plus j here, times ax cap, and you have minus of minus, it gives you a y, so you get a plus ay times of I think somewhere I have misplaced, oh sorry, okay, I think I didn't, right, so ay times of uh, minus of minus, it becomes plus, and beta is taken common out, so you're left with 40 times of, maybe I read for magnitude before, so it is 40 into e power minus j beta z times ay cap. Okay, so here if you see beta by omega mu naught, beta is nothing but omega square root of mu naught into epsilon naught, and you divide it by omega mu naught. Okay, so you'll end up with omega cancelling out, and you'll end up with square root of mu naught by epsilon naught, which is nothing but eta naught. So I can replace this whole factor, I'm sorry, this is nothing but 1 by eta naught. Okay, so you get here mu naught gets cancelled, so square root, so you get epsilon naught by mu naught, so which is 1 by eta naught. Okay, so I can replace this with 1 by eta naught. So you can see this is your expression for magnetic field. Okay, so if you know the value of eta naught, you can basically substitute it there and you can get the answer. So of course what we can do is, if you want to convert it into, because we had it in phasor format now, you can always convert it back into time domain. So if I want to convert it back into time domain, how do I do it? You just multiply it with e power j omega t, this whole thing. So I guess let me, because there is 30 and 40 here, it's better you can write eta naught as 120 pi. So I get something like if I cancel this out, I get 1 by 4 pi times of j times of e power minus j beta z ax cap plus 1 by 3 pi times of e power minus j beta z ay cap. So now you want to convert into time domain, you multiply this whole thing with e power j omega t and take a real part of it. So when I take a real part of it, what I have to replace it with j? J ne, I can replace it with e power j pi by 2. Okay, so what I will get is, when I convert into time domain, okay, so this is what I will be getting. So when you multiply with e power j omega t and take a real part of it, you get 1 by 4 pi times of cos of omega t minus beta z, and there is a plus pi by 2 here, so you get a plus pi by 2 times of ax cap plus 1 by 3 pi times of cos of omega t minus beta z, which is an ay cap direction. Now there is a plus pi by 2, so cos of something plus pi by 2, I say it becomes minus sine. So you have minus sine minus 1 by 4 pi sine omega t x cap direction plus 1 by 3 pi milliamp means you get cos omega t minus beta z ay cap direction. Okay, so your unit is ampere per meter for the magnetic field. So I hope we have the value for the first case. We have the magnetic field expression. So the second question asks for what is a reflected field and what is a reflected magnetic field also. So how do we calculate both the reflected and reflected magnetic fields? And first you need to calculate the reflected electric field, and from there you can calculate the reflected magnetic field from our analysis, right? Just like we have done previously. So let us do that. So here, to get the reflected field, because it's a perfect electric conductor, I know the reflection coefficient here is -1. So that means whatever magnitude of electric field you have, I mean not the means I can say, because the incident electric field, the reflected electric field by the incident electric field, okay, means except the phase constants, the ratio between them is equal to -1. So let us try to use this equation. So I can say that can I, because ER by EI is -1, can I simply write అంటే ఇక్కడున్న EI కి ER ఎంత అంటే సింప్లీ ముందు మైనస్ సైన్ పెట్టేస్తే అయిపోద్దా సార్ ఆన్సర్ అంటే మేబీ ఇట్ వోంట్ బి దట్ మచ్ సింపుల్. ఫస్ట్ ఆఫ్ ఆల్ ఎందుకంటే if I just simply because ER by EI is -1, I can say ER is nothing but minus of EI. So people can simply write it as -40 cos of omega t minus beta z ax cap minus 30 times of sine omega t minus beta z ay cap. And of course there is a huge mistake in this problem, because the problem with this kind of solution is you can see that it is cos omega t minus beta z indicates it's a wave traveling in positive z direction. So that is a wave traveling like this. But a reflected wave actually travels like this. Okay, it travels in negative z direction. So if there is a negative z direction, you need to have cos of omega t plus beta z kind of structure, okay, which is not here. So you cannot simply put a minus sign there. So first of all, what you have to do is you have to write your electric fields in phasor format. So that is important. So in fact we have written our electric fields in phasor format. Your incident electric field is given like this. So you had 40 ax cap, right, into plus, I mean you got a minus j times of 30 ay cap into e power minus j beta z. So this is what we have for an incident electric field. I know the reflected electric field is simply with a minus sign, so I can say that the reflected electric field is negative of this factor, so which is minus 40 times of ax cap plus j times of 30 ay cap, okay, times e power, because now it's a wave traveling in backward direction, so you need to write j power j beta z, okay. So keeping this in mind, if you want to convert this now into time domain, so you can simply multiply it with e power j omega t and take real part of it. So I'm writing the answer for that process, but you have to solve it. So it is minus 40, you get cos of omega t plus beta z now in ax cap direction, and for the j you get cos of something plus pi by 2. So that's why you get a minus sign here again, minus 30 sine omega t minus beta z, sorry, plus beta z ay cap. So in fact you can see it is as simple as putting a minus sign, but it is not just you put a minus sign, but you need to cover up for this direction of the phase change also, right? So your wave direction here is minus positive z direction, so you need to put plus beta z to indicate that it's a wave traveling in positive z direction. So if I have an electric field, how do I calculate the magnetic field? So the process is always same. The magnetic field is given by 1 by omega mu k bar cross h bar. So I have the h bar e bar vector, sorry, k bar cross e bar. So I have the e bar vector, and I know what is means omega naught is not known, mu is mu naught. And what is k bar? K bar vector in our scenario now, what is a k bar vector? So if you write k bar vector is beta times of az cap, then you are mistaken again. Okay, because that is the k bar vector for the incident wave. So for the reflected wave, k bar vector is minus beta times of az cap because it's a wave traveling in opposite direction, you can see here. So if that is your scenario, okay, so if this is your k bar vector, okay, then if you substitute it here, okay, you have to basically take cross product between, like this becomes 1 by omega mu naught k bar, and I can replace it with minus az cap, cross product with the electric field. Okay, so this is your electric field vector, and there is some here you can bring out beta out. So beta by omega mu naught is nothing but 1 by eta naught. So you basically have to take az cross e bar. Okay, so if I do that, I'll get the answer for the magnetic field like this. So let me write it. So you have 1 by eta naught in the front. So 1 by eta naught. So you take cross product of minus az with minus ax. So you can see that minus minus goes to plus, and the az cross ax gives you ay. So you get 40 times of ay, and az cross ay. So usually ay cross az gives you ax, but here there is an az cross ay. It should give you minus ax, but there is already a minus sign, so it gives you a plus. So you get plus j times of 30 into ax cap. Okay, and 2 e power plus j beta z. So this is your time domain. If you wanted to convert into means this is in phasor format. So if you want to convert it into time domain, so simply take multiply it with e power j omega t and take a real part of it. You will end up with because there is j30, so j is nothing but e power j pi by 2. So you get cos of omega t plus beta z plus pi by 2 in your phasor format. So because of that plus pi by 2, you get a minus sign for ax component. So you get something like 1 by 4 pi times of sine omega t plus beta z times ax cap plus 1 by 3 pi cos of omega t plus beta z ay cap. So though I have written it here, I just want you to pause the video and you try to see how you arrive this equation, right? So not only here, at any point when I'm converting a field from phasor format to time domain, I'm converting a field from time domain to phasor format. You just don't watch how I'm doing it. It's better you always pause the video and you try to see try to get that transformation by yourself, so that you can get a lot of practice of doing it. Okay, because usually we always go from time domain to phasor domain and phasor domain to time domain, so that is needed. Okay, so this is your electric field. So if you ask me what is the total electric field for z less than 0 region, so we know that for z greater than 0 there is no field because it's a perfect electric conductor, there are no fields. For z less than 0, I can say the total electric field is nothing but the incident electric field plus the reflected electric field. Basically I have the incident electric and magnetic field expressions, and reflected electric field and reflected magnetic field expression. So simply I can stick it here to calculate the total field as incident magnetic field plus reflected magnetic field. So basically add up those expressions to get your answer. So that is an easy one to do. Okay, then the last question here is to calculate the time average power, okay, for z less than 0 and for z greater than 0. So we know that because at z equal to 0 there is a perfect electric conductor, and we know that there are no transmitted fields in this region. So when a wave is incident normally, it is reflected back. So what is the power that is going for z greater than 0, because there are no fields. Okay, so there is no power or no time average pointing vector here. So there is no S average bar pointing vector, there is no time average pointing vector. But what about here? Because you have fields here, there is incident field and there is a reflected field. So now the question asks for what is the total time average power. So what is the total time average power is, interestingly, it should get an answer of 0, because because we know that whatever power is coming here, the total power is reflected back because the reflection coefficient is -1. So because the reflection coefficient is -1, usually the total power is reflected back. But in fact, you can prove it. Okay, but if the reflection coefficient is not -1, but it is a number which is less than 1, then some amount of power will be transmitted into the other side of the region. Then maybe the boundary is not PEC. Then something can happen like this field cannot be equal to 0. Then even though there is a forward and a backward wave, there is a standing wave, you can see that there is a finite amount of power that is propagating into the other side of the region. Okay, but there is some reactive power, of course. That is what we will see here. Okay, so if it is a PUC, we see that the total power cancels out. Means what? Meaning cancel out, I mean, since whatever average power is coming in this direction is equal to the average power that is going back. So you can simply show it by taking that if the electric field, okay, if I have my incident electric field is like this, so the incident electric field is like some E naught I bar, okay, E naught I bar into e power minus j beta z is your expression. Okay, and your reflected electric field is like this, E naught r bar times e power plus j beta z. So this is your fields, these are your fields, right? So because they are uniform plane waves, I know that the average power, the time average power is of course is nothing but modulus of this E naught I bar square, okay, divided by 2 times of eta naught, because it's free space. Basically this is air, so it is free space. Okay, and of course because it's a vector, I need to write the direction. I know the direction here because the wave is traveling in z direction. Usually you get az cap. Okay, so without doing cross product and all, I'm directly assuming, means I'm getting the answer here. But of course you can always go back to your basic, that is S average power for the input for the incident wave is nothing but half times of real part of ei cross hi conjugate. Okay, so we have the ei and hi expressions in phasor format, very important. Okay, phasor format like equations ni ikkada substitute cheyali. So that is why I was converting the values from phasor to time domain. ఎందుకంటే పవర్ క్యాలిక్యులేట్ చేయాలి అంటే you need them in phasor format, time average power. So you can put them, in fact you'll end up with this kind of equation. And of course what is the reflected wave? So this is for the incident wave. If you ask me what is an time average power for the reflected wave, you get something like E naught r square divided by 2 times of eta naught into az cap. Okay, so of course this is a wave that is coming back, so you get a minus az cap, because the wave, the reflected wave is going in negative z direction, you get a minus az cap. Maybe I will put it here so that you don't get confused. So minus az cap, so that is your direction. So we know that the magnitude, this electric field vectors, they are related by factor of reflection coefficient tau. So in place of this E naught r bar, I can replace it with magnitude of tau times of E naught I bar. Okay, so I can write the same expression as magnitude of tau square times magnitude of E naught I square divided by 2 eta naught times of minus az cap. So you can see the magnitude of reflection coefficient is equal to 1, and so that means this power is exactly equal to your incident wave power, and it is in opposite direction. You can see the direction is minus az cap. So whatever power is coming in, that power is going out. So if you ask me what is the total power, okay, what is the total time average power, then the total time average power will be 0, because here whatever power is coming in is completely reflected back, and the standing wave is not going to deliver any power. So the total time average power will be equal to 0. So so these are some problems. We'll also look into other problems.